So good day everyone. Before I start to discuss my topic, let me introduce myself first. So, I am Arabia Lipae, the first reporter. So, the learning objectives. By the end of this chapter, you should be able to define correlational research and describe when to use it and how it developed. Identify the two types of correlational designs. Describe the key characteristics of correlational designs. Identify the potential ethical issues in conducting correlational research. Identify steps in conducting a correlational study. And the last, list the criteria for evaluating a correlational study. So, what is correlational research? When do you use it and how did it develop? Correlational designs provide an opportunity for you to predict scores and explain the relationship among variables. A correlation is a statistical test to determine the tendency or pattern for two or more variables or two sets of data to vary consistently. Covary means that we can predict the score on one variables with knowledge about the individual score on another variable. So, correlational research designs allow researchers to examine the relationship between variables without necessarily implying causation. In other words, they help to understand how variables are related to each other. So when we say two two variables covary, it means that they tend to change together in a predictable manner. For example, let's consider the relationship between study time and exam scores. If there's a positive correlation between these two variables, it means that as study time increases, exam scores also tend to increase. Conversely, if there's a negative correlation, it means that as the study time increases, exam scores tend to decrease. The next is, when do you use correlational research? You use this design when you seek to relate two or more variables to see if they influence each other, such as the relationship between teachers who endorse developmentally appropriate practices and their use of the whole language approach to reading instruction. Next is, how did correlational research develop? Correlational research began in the late 19th century, with statisticians developing ways to measure the relationship between two variables. Carl Pearson in 1895 introduced the familiar correlation formula we use today. He drew on Darwin's evolution theory and Galton's ideas on inheritance to explain correlations. Other statisticians like the the Yule, Pearson's student, and Spearman, Pearson Rue, further refined these ideas, developing methods to correlate multiple variables. For about 50 years, experimental procedures were more popular in research, but in 1963, Campbell and Stanley's work brought new attention to correlational research, though they saw it as less rigorous than experiments. With the rise of computers in the 1970s and 1980s, researchers could conduct more complex correlational studies, examining relationships among many variables instead of physical control like in experiments. They relied on statistical procedures to control variables. Today, researchers use advanced techniques like multiple regression and path analysis to study elaborate models with many variables. So the next is, what are the types of correlational designs? The two primary correlation designs are explanation and prediction. So the first is the explanatory design. Consists of a simple association between two variables. Example, sense of humor and performance in drama. Or more than two. Example, pressure from friends or feelings of isolation that contribute to binge drinking. So, the explanatory design, also known as an explanatory correlational design, it focuses on understanding the extent to which two or more variables co-vary. This means the researcher aims to explore how changes in one variable are reflected in changes in another. So the second one is the prediction design. Is to Prediction design is to identify variables that will predict an outcome or criterion. In this form of research, the investigator identifies one or more predictor variable and a criterion or outcome variable. So, prediction designs is like they they can help practitioners and policymakers make informed decisions and develop strategies to enhance desired outcomes. Then, so the next, what are the key characteristics of correlational designs? As suggested by the explanatory and prediction designs, correlation research includes specific characteristics: displays of scores, scatter plots, and matrices, associations between scores, direction, form, and strength, multiple variable analysis, partial correlations, and multiple regressions. Then, next, displays of scores. If you have two scores in correlation research, you can plot these scores on a graph or scatter plot or present them in a table or correlation matrix. And scatter plots. Researchers plot scores for two variables on a graph to provide a visual picture of the form of the scores. So as we can see in this figure, in this table, we can see the example of a scatter plot graph. So as shown in figure 11.1, hypothetical scores for 10 students are collected and plotted on the graph. Several aspects about this graph will help you understand it. So, the hours of internet use. Variable is plotted on the x-axis, the horizontal axis. So that is the x-axis. The depression variable is plotted on the y-axis, the vertical axis. So each student in the study has two scores. One for hours per week of internet use and one for depression. Mark or point on the graph indicates the score for each individual on depression and hours of internet use each week. There are 10 scores or points on the graph, right? One for each participant in the study. This means scores or M on each variable are also plotted on the graph. The students use the internet for an average of 9.7 hours per week, and their average depression score was 29.3. So, drawing vertical and horizontal lines on the graph that relate to the mean scores. And in our example, to have a depression score below 29.3 is positive because that suggests that the students with such a score have less depression. To score above 29.3 indicates more severe depression, and this is negative. Alternatively, to use the internet less than 9.7 hours per week is positive because students can then spend more time on homework, whereas to spend more time than 9.7 hours is negative. Overuse of internet searching is at the expense of something else. To be both highly depressed, above 29.3 on depression, and to use the internet frequently, above 9.7 on internet use, is what we might have predicted based on past literature. So the next is correlation matrix. Correlation researchers typically display correlation coefficients in matrix. So correlation matrix presents a visual display of the correlation coefficients for all variables in a study. So an example of this can be seen in table 11.1, which reports coefficients for the correlation of 6 variables in a study of variables associated with school satisfaction among middle school students. This that all 6 variables are listed in both the horizontal rows and the vertical columns. To simplify the table, the authors assigned numbers to the variable and included only the numbers in the column heading. Then, linear relationship. Part A of Figure 11.2 depicts a positive linear relationship of scores where low or high scores on one variable relate to low or high scores on a second variable. Part B of Figure 11.2 depicts a negative linear relationship result where low scores on one variable relate to high scores on the other variable. Uncorrelated and nonlinear relationships in Part C, Figure 11.2. We see a non-correlated relationships of scores. In this distribution, the variables are independent of each other. A curvilinear distribution or nonlinear relationship shows a U-shaped relationship in scores. What multiple variable analysis? In many correlation studies, researchers predict outcomes based on more than one predictor variable. Partial correlations. In many research situations, we study 3, 4, or 5 variables as predictors of outcomes. Multiple regression. Correlation researchers use the correlation statistic to predict future scores. So we can see the figure 11.3, the common variance shared for bivariate and partial correlation. A picture of two variables followed by the inclusion of a third can help explain partial correlations. Examine figure 11.3, which shows a bivariate or two variable correlation on the left hand side and a partial three variable correlation analysis on the right hand side. Assume that a researcher conducts a study correlating time on task with achievement for middle school children. After gathering the scores, our investigator calculates our correlation coefficients with the results of R equals to 0.50. Figure 11.3 indicates this association as well as the R squared, or the proportion of common shared variance between the two variables. However, the situation is more complicated. Student motivation, a third variable, may also influence both the students' time on task as well as their achievement in class. The researcher identifies this third variable based on a literature review and a study of past theories that have shown factors likely to influence students' achievement. In the design, motivation needs to be removed so that the relationship between time on task and achievement can be more clearly determined. A partial correlation statistical analysis is used that removes the shared variance in both time on task and achievement by motivation. The hatch mark area indicates this shared variance left after removing the effects of motivation, and the R squared equals to 0.35 close and open parenthesis squared is now lower than the original correlation of R equal to 0.50. The next is multiple regression. Correlation researchers use the correlation statistic to predict future scores. So next is a regression line. A regression line is a line of best fit for all of the points of scores on the graph. This line comes the closest to all of the points on the plot, and it is calculated by drawing a line that minimizes the square distance of the points from the line. Examine figure 11.4, which is the same graph used in figure 11.11. Figure 11.4 now contains additional information, more detail about the regression line. You can see how the line comes close to all of the points on the graph, and we draw it at a diagonal consistent with the positive correlation between internet use and depression scores. The calculation of this line holds value for predicting scores on the outcome. Based on a mathematical formula, our researcher can calculate an equation that expresses this line. So y is, we call it predicted, equal to b close and open parenthesis x plus a, where y is predicted score on depression, x actual score on number of hours of internet, b equals to slope of the regression line called the unstandardized regression coefficient, a equals to the intercept or a constant, the value of the predicted y or depression score when x equals to 0. We would expect an individual who uses the internet 14 hours per week to have a depression score of 41. This score can be estimated by drawing a vertical line from the score for the x-axis variable up to the regression line and over to the y-axis variable. Alternatively, using the regression formula, if a equals to 6, b equals to 2.5, and x equals to 14, then y is predicted right. Y. And the equals to 2.5 times 14, 35, plus 6 equals to 41. That's how we solve it. Examine the regression table shown in Table 11.2. We can calculate regression coefficients for each variable, assess the combined influence of all variables, and provide a picture of the results. So, a regression table shows the overall amount of a variance explained in a dependent variable by all independent variables called R squared. It also shows the regression weight, the amount of contribution of each variable controlling for the variance of all other variables, called beta. For each variable in Table 11.2, we see four predictor variables of student learning. The coefficients in the right column are the beta weight for each independent variable. Beta weight is a coefficient indicating the magnitude of prediction for a variable after removing the effects of all other predictors. As seen in table 11.2, the predictor prior achievement explains the most variance, followed by motivation. Below the table, we see the correlation of the combination of variables. The multiple correlation designated by R of 0.38 and the proportion of variability explained in the dependent variables by all of the predictors R squared of 0.14. Recall that the value R squared, called the coefficient of determination, represents the proportion of variability explained by the independent variables in the dependent variable. In reporting results, correlational researchers should indicate not only the statistical significance of the test but also the effect size variance of the R squared. So, meta-analysis. In another extension of correlation research, authors integrate the findings of many primary source research studies in a meta-analysis by evaluating the results of individual studies and deriving an overall numeric index of the magnitude of results. The intent of this research is to summarize the results of many studies, illustrations of meta-analysis study as well as the difference between a primary and secondary source of information is seen in figure 11.5. In the top section, we see the first page of primary source research report, an investigation by Smetana and Askiev, 1994. They examine the types of parent authority and ratings of adolescent-parent conflict for 68 6th, 8th, and 10th graders and their parents. In the bottom section of figure 11.5, we see that the original research by Smetana and Ashkit in 1994 is included as one of 27 studies reported in a secondary source. A meta-analysis published by Lorsen, Coy, and Collins in 1998. The 27 studies shown in the table integrated research examining parent-child conflict changes during early, mid, and late adolescence. Potential ethical issues in conducting correlational research. So, correlational research is great for understanding relationships between variables, but it comes with ethical considerations. These include how data is collected, analyzed, and reported. Researchers need to be mindful of these ethical concerns throughout their study. This includes considerations mentioned in sources like Brown and Hedges in 2009.
So, good afternoon, sir. We will proceed to the next topic, which is the ethical dilemma. So, ethical dilemma is a type of ethical issue that arises when the available choices and obligations in a specific situation do not allow for an ethical outcome. So describing results inappropriately. So, a key concept in correlational research is understanding the difference between causation by an independent variable on a dependent variable and an association or a relationship. So, because all variables cannot be tightly controlled in a correlational study, the researcher cannot make claims about causation or probable causation because nothing can be absolutely proved. So instead, claims of association or relationship, a lesser standard can only apply. So this impacts how educational researchers write up the results from their correlational studies. So it is considered to be an ethical problem when the write-up misconstrues the result to be cause and effect. So, what the next one is, what are the steps in conducting a correlational study? So, as a researcher, when we conduct a correlational study, we must follow a steps on how to properly conduct a correlational study. So from our discussion about the key characteristics of correlational research, we can begin to see steps emerge that you might use when planning or conducting study. So the steps in conducting a correlational study are to use the design for associating variables or making predictions, to identify individuals to study, to specify two or more measures for each individual, to collect data and monitor potential threats to the validity of the scores, to analyze the data using the correlation statistic for either continuous or categorical data, and to interpret the strength and the direction of the results. So these are the following steps illustrate the process of conducting correlational research. So step 1 is determine if a correlational study best addresses the research problem. So it is used when a need exists to study a problem requiring the identification of the direction and degree of association between two sets of scores. So it is useful for identifying the type of association, explaining complex relationship of multiple factors that explain an outcome, and predicting an outcome from one or more predictors. A correlational research prove does not prove a relationship, rather, it indicates an association between two or more variables. So, it is very important for us to choose the correct research design for us to easily understand and get the correct answer to the problem. And also, correlational research investigates relationships between variables without the researcher controlling or manipulating any of them. So the step 2 is identify individuals to study. So ideally, you should randomly select the individuals to generalize results to the population and seek permissions to collect the data from responsible authorities and from the institutional review board. So the group needs to be of adequate size for use of the correlational statistics such as n equals 30. Larger sizes contribute to less error variance and better claims of representativeness. So for instance, a researcher might study 100 high school athletes to correlate the extent of their participation in different sports and their use of tobacco. So a narrow range of scores from a population may influence the strength of the correlation relationships. Like for example, if you look at the relationship between the height of basketball players and the number of baskets in a game, you might find a strong relationship among the K-12 graders. But if you are selecting NBA players, this relationship may be significantly weaker. So in selecting a participants to our research, we must consider that they are appropriate. Like for example, if your topic is all about the basketball players, so the participants must be playing basketball, and by this we can solve and collect better results. So step 3, identify two or more measures for each individual in the study. So because the basic idea of correlational research is to compare participants in the single group on two or more characteristics, measures of variables in the research questions need to be identified. Like for example, literature search of past studies. And instruments that measure the variables need to be obtained. Ideally, these instruments should have proven validity and reliability. You can obtain permission from publishers or authors to use the instruments. Typically, one variable is measured on each instrument, but a single instrument might contain both variables being correlated in the study. So, in this step, which is the step 3, is the correlational research is a statistical measure that describes the size and direction of a relationship between two or more variables. It is also allows us to discover the strength and direction of relationships that exist between two variables. So next is step 4, collect data and monitor potential threats. So the next step is to administer the instrument and collect at least 2 sets of data from each individual. So the actual research design is quite simple as a visual presentation. So 2 data scores are collected for each individual until you obtain scores from each person in the study. So these illustrated with the 3 individuals as follows. So we can see in the screen that we have 3 participants and each measures and observations of each participants or individuals are the same, which is the measure is 0,1 while the observation is 0,2. So this situation holds for describing the association between two variables or for predicting a single outcome from a single predictor variable. So you collect multiple independent variables to understand a complex relationships. So we have also a sample database for 10 college students that we will show in the screen. So based on the image flashes in the screen it indicates that the investigator seeks to explain the variability in first year grade point average or GPAs for these 10 graduate students in education. So assume that our investigator has identified these 4 predictors in a review of the literature. So in past studies, these predictors have positively correlated with achievement in college. So the researcher can obtain information for the predictor variables from the college admissions office. So the criterion GPA during the first year is available from the registrar's office. So in this regression study, the researcher seeks to identify which one factor or combination of factors best explains the variance in first-year graduate student GPAs. So a review of this data shows that the scores varied on each variable, with more variation among GRE scores than among recommendation and fit-to-program scores. So also, it appears that higher college GPA and GRE scores are positively related to higher first semester GPAs. So in this example, because the data were available from admissions offices, the researcher need not be overly concerned about procedures that threaten the validity of the scores. So however, a potential for restricted range of scores, little variation in scores certainly exists. Other factors that might affect the researcher's ability to draw valid inferences from the results are the lack of standards administration procedures, the conditions of the testing situation, and the expectations of participants. So the step 5 is analyze the data and represent the results. So the objective in correlational research is to describe the degree of association between two or more variables. So the investigator looks for a pattern of responses and uses statistical procedures to determine the strength and relationship as well as its direction. So a statistically significant relationship, if found, does not imply causation or cause and effect, but merely an association between the variables. More rigorous procedures, such as those used in experiments, can provide better control than those used in correlational study. So the analysis begins with coding the data and transferring it from the instruments into a computer life. Then the researcher needs to determine the appropriate statistic to use. An initial question is whether the data are linearly or curvilinearly related. a scatter plot of the scores if a bivariate or bivariate study can help determine this question. So, also consider whether only one independent variable is being studied or Pearson's correlation coefficient. When we say Pearson's correlation coefficient, is when you have two quantitative variables that you wish to see if there is a linear relationship between two variables. The next is a mediating variable explains both the independent and dependent variables and needs to be controlled, or what we call partial correlation coefficient. So when we say partial correlation coefficient, it is a coefficient to describe the relationship between and when taking away the effects of control variable, which can be used to test conditional independence. The next is more than one independent variable needs to be studied to explain the variability in a dependent variable, or what we call multiple regression coefficient. So when we say multiple regression coefficient, it signifies the amount by which change in x must be multiplied to give the corresponding average change in y, or the amount y changes for a unit increases in x. So in this way, it represents the degree to which the line slopes upwards or downwards. So based on the most appropriate statistical test, the researcher next calculates whether the statistic is significant based on the scores. So, for example, a p-value is obtained in a bivariate or bivariate study by setting the alpha level using the critical values of an R table available in many statistics books, using degrees of freedom of n equals 2 with this table, calculating the observed R coefficient and comparing it with the R critical value, rejecting or failing to reject the null hypothesis at a specific significance level. So, such as p-value 0.05. So, when we say p-value 0.05 it means that the test hypothesis is false or should be rejected. Next is step 6, interpret the results. So the final step in conducting a correlational study is interpreting the meaning of the results. This requires discussing the magnitude and the direction of the results in a correlational study, considering the impact of intervening variables in a regression analysis, and developing a predictive equation for use in a prediction study. So the last part, which is the interpret the results, is after conducting a research and we get the results of our research, we must interpret the results so that we can get the meaning of the results that we have. So in all of these steps, an overall concern is whether your data supports the theory, the hypothesis, or questions. Further, the researcher considers whether the results confirm or disconfirm findings from other studies. Also, a reflection is made about whether some of the threats discussed above may have contributed to erroneous coefficients and the steps that might be taken by future researchers to address these concerns. So, we should always put in our mind that our results should support the theory, the hypothesis, or questions of our research. So the next one is, how do you evaluate a correlational study? To evaluate a correlational study in terms of the strength of its data collection, analysis, and interpretations, these factors include adequate sample size, good presentations in graphs and matrices, clear procedures, and an interpretation about the relationship among variables. So, to evaluate and assess the quality of a good correlational study, authors consider an adequate sample size for hypothesis testing, the display of correlational results in a matrix or graph, an interpretation about the direction and magnitude of the association between two or more variables. So for us to have a better understanding about our results on our research is we must put the results in a matrix or a graph for better understanding. The next one is an assessment of the magnitude of the relationship based on the coefficient of determination, p-values, effect size, or the size of the coefficient, the choice of an appropriate statistic for analysis, the identification of predictor and the criterion variables. If a visual model of the relationships is advanced, the researcher indicates their expected direction of the relationships among variables or the predicted direction based on observed data. The clear identification of the statistical procedures. So the next is key ideas in the chapter or the definition, use, and development of correlational research. So in some educational situations, neither the treatment nor the ability to manipulate the conditions are conducive to an experiment. So in this case, educators turn to a correlational design. So in correlational research, investigators use a correlation statistical technique to describe and measure the degree of association or the relationship between two or more variables or sets of scores. So you use a correlational design to study the relationship between two or more variables or to predict an outcome. So we usually use a correlational research if we want to know the relationship between academic performance and career success, between physical and emotional violence on adolescents' mental health, and etc. So the next is types of correlational designs. So although a correlation is a statistic, its use in research has contributed to a specific research design called correlational research. So this research has taken two primary forms of research designs, which is the explanation and prediction. So an explanatory correlational design explains or clarifies the degree of association among two or more variables at one point in time. An example is whether motivation is associated with academic performance. The second is the prediction design. So the investigator identifies variables that will positively predict an outcome or criterion. So in this form of research, the researcher uses one or more predictor variables and a criterion or outcome variable. A prediction permits us to forecast future performance, such as whether a student's GPA in college can be predicted from his or her high school performance. So the next is key characteristics of correlational designs. So underlying both of these designs are key characteristics of correlational research. So researchers create displays of scores correlated for participants. These displays are scatter plots. Scatter plots is it identifies a possible relationship between changes observed in two different sets of variables. It provides a visual and statistical means to test the strength of a relationship between two variables. It is a chart type that is normally used to observe and visually display the relationship between variables. It is also known as a scattergram, scatter graph, or scatter chart. So, graphic representation of the data. So, when we say graphic representation or graphic presentation, it is another way of analyzing numerical data. A graph is a chart through which data are represented in the form of lines or curves drawn across the coordinated points plotted on the surface. Graphs enable us in studying the relationship between two variables and the correlation matrices or matrices, a table that shows the correlation among all the variables. To interpret correlations, researchers examine the positive or negative direction of the correlation of scores, a plot of distributions of scores to see if they normally or non-normally distributed, the degree of associations between scores, and the strength of the association of the scores. So when more than two variables are correlated, the researcher is interested in controlling the effects of the third variable and in examining a prediction equation of multiple variables that explains the outcome. So the next and the last topic is the ethical issues in conducting correlational research. So ethical issues arise in many phases of the correlational research process. In data collection, ethics relate to adequate sample size, lack of control, and the inclusion of as many predictions as possible. So in data analysis, researchers need a complete statement of findings to include effect size and the use of appropriate statistics. So analysis cannot include making up data. In recording and presenting studies, the write-up should include statements about relationships rather than causation, a willingness to share data, and publishing scholarly outlets. So in conducting a research DAO we must be careful and be aware of what we write. We should always remember that the contents of your research must be based on facts, not opinions. Also, some ethical issues we might encounter are the plagiarism, breach of confidentiality, coercion, and many more. So to avoid encountering these kinds of ethical issues, we must respect the confidentiality of your participants and follow the given rules that your instructor